All right, looking here at problem 18, and we've got this omega and omega not equaling 1 being a solution here. And so when we know omega is not equal to 1, we know it's not the obvious solution. When I look at z cubed minus 1 equals 0, the obvious solution is 1. 1 cubed minus 1 is 0. And so we know that we can factor this to be z minus 1 times something. And the thing that we can factor it to, if we just kind of start building it up, z times z squared is z cubed, but then I have an extra negative z squared. So I add a positive z. Z times z is z squared, but then I have an extra negative z. And so I go plus 1 to counteract with that. And this does distribute out to give me z cubed minus 1. So I can use that expression right there. And then this shows me that if I substitute in omega, which I just draw looking like a W, that this should also be true because we know that omega is a solution. Omega is a solution to the original problem. We also know that omega does not equal 1, so I can ignore that. I can divide by it because it's not equal to 1. So dividing by omega minus 1 is not equal to 0. And then I have this wonderful conclusion. Omega squared plus omega plus 1 has to equal 0. So I'm going to use that to see what I can discover about these other expressions. Um, okay, I'm not seeing anything super obvious right off the bat, but let's try. So we have 1 plus omega plus the conjugate, omega star squared. So we'll write it down twice. Cross out the 2. So that gives me 1 plus omega plus the conjugate. That's distributing the 1. Then plus omega squared plus omega times omega conjugate. That's distributing the omega. Now I'm going to distribute the conjugate. And the thing that I just figured out over here on the right side is that 1 plus omega squared is 0. So if I can go 1 and omega squared, that equals 0. So I can get rid of that. Let's see, what do we have left over now? A lot of other stuff. Let's see. Is there a nice thing that happens with omega times omega conjugate? I can't remember. I think there is a nice thing about omega times omega conjugate. Let's see. Let's just try to write it out. Omega is going to be a plus bi. Omega conjugate is going to be a minus bi. Omega times omega conjugate is a plus bi times a minus bi is going to be a squared plus abi minus b squared I squared, which becomes a squared plus b squared. And here's the nice thing. A squared plus b squared is equal to 1. Now, how did I make that last conclusion that a squared plus b squared equals 1? It's not always true, but it is true here because we know that omega is a solution of z cubed minus 1 equals 0. And so the only possibility is that the a squared plus b squared has to equal 1 in order for it to be a solution of z cubed minus 1. So then I can go back through now and say that anytime I see omega times omega conjugate, that's going to equal 1. So here's another 1. So let's write down what we have left over. We have an omega. We have 2 1s. We have 2 omega conjugates. We have an omega conjugate squared. Okay, can we do any better? Let's see here. We also know that omega over here is the solution to a quadratic. And so if omega is the solution to this quadratic, then so is omega conjugate. If you think about the quadratic formula gives you two solutions in terms of a conjugate pair. And so if I know that this statement right here is true, I also know that omega conjugate squared plus omega conjugate plus 1 has to equal 0. So I think what we can do then is split this expression up into omega plus 1 plus another 1 plus omega conjugate plus omega conjugate squared, and we got one more omega conjugate left over. I can zero out the expression that I just came up with on the right, leaving me with this omega plus 1 plus omega conjugate. If we use the a and the b from down here, we could even go a little bit further and say that that's equal to 2a plus 1. I think that I would prefer this version of the answer, but this version is also correct, although we just don't know much more about the omega. I guess we could even go a little further because we know what the cube roots of unity are. The cube roots of unity are just evenly spaced around the unit circle. And so I actually even know that the a value is whatever the cosine of 120 degrees is. And the cosine of 120 degrees is negative 1/2. And so we can even go a little further and say 2 times negative 1/2 plus 1, which of course everything cancels out and equals 0. Okay, so part A is equal to 0. A lot of work to get a 0. If you look at part B, it's going to be a sort of similar process. Let's see, is there a nice easy way to do this? Let's see, I don't know if there's an easier way to do it. 1 plus omega plus 3 omega squared becomes 1 plus omega plus 3 omega squared plus omega squared plus 3 omega cubed plus 3 omega squared plus 3 omega cubed plus 9 omega to the fourth. So 1 plus 2 omega plus 7 omega squared plus 6 omega cubed plus 9 omega to the fourth. That doesn't look super nice. Okay, better approach than that. The original expression on part B can be written like this: 1 plus omega squared plus 2 extra omega squareds. And we talked about a couple times how this has to equal 0. And so we can simplify it down, and we end up with just 2 omega squared, which becomes 4 omega to the fourth. There you go. We can't go farther than that because omega could be either the 120 degree solution or the 240 degree solution, and without knowing which one, we don't have a further expression. Okay, let's see. Part C. What happens in part C? Let's do that same trick. So if I do 1 plus omega squared, it equals 0. And so the left parentheses just becomes omega plus 2 omega squared. And the right parentheses becomes 2 omega plus omega squared. Those both have an omega in common. And so I can write omega squared in front and then make this left side into 1 plus omega and make the right side into 2. I'm sorry, that's not right. 1 plus 2 omega, make the left side or the right side into 2 plus omega. And so then we get omega squared times 2 plus omega plus 4 omega plus 2 omega squared. We can knock out here. We've got a 2. This is at least 2, and this is 2. So if I take out those, because omega 1 plus omega squared equals 0, and so 2 plus 2 omega plus 2 omega squared equals 0. So then we have omega squared over here, and we have 1, 2, 3 omegas left over, which leaves us with 3 omega cubed. There you go. So I had to get a little fancy with it, but that makes sense. That's how you get through it. All right, please let me know if I made a mistake or if anything didn't make sense.